projects. In this video, we are going to explain about crowd counting. Introduction. The project's goal is to develop a crowd counting system based on a convolutional neural network CNN trained on the model dataset. Crowd counting is a method of counting or estimating the number of individuals in a photograph. Estimating the number of people or objects in a single photograph is a difficult but important task that has been used in numerous applications such as urban planning and public safety. Crowd counting is very prominent in the numerous object counting jobs because of its particular importance to social security and development. Objective. The goal of the project is to develop a crowd counting system that makes use of trained convolutional neural network CNN and the MAUL dataset. Object counting is a challenging problem in which we have an image and must count all of the specific object on that image. This becomes intractable in the setting of big data and the Internet of Things when we have video tracking and must count the object in each frame. An artificial procedure such as machine learning algorithm can solve this problem by receiving an image as input and returning the number of some object of interest in the image. The major purpose of the project is to provide practical and accurate crowd counting system. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system Windows only, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. In software requirements, we have Python IDEL with 3.7 version. Methodology. To implement this project, we have designed the following modules. The first module is Load CNN Model. This module is responsible for loading the pre-trained convolutional neural network model into the application. The CNN model has been trained using the MAUL dataset to perform crowd counting. Loading the model at the beginning of the application ensures that it is ready for use in subsequent models to predict crowd counts accurately. Second module is Upload Image and Count Crowd. In this module, users can upload any image containing a crowd, and the application will apply the pre-trained CNN model to count the number of individuals in the image. The CNN model utilizes its learned features and knowledge from the MAUL dataset to make accurate predictions about the crowd count in the uploaded image. Third module is Upload Video and Count Crowd. Similar to the Upload Image and Count Crowd module, this module allows users to upload any video containing crowds. The pre-trained CNN model is applied to each frame of the video to count the number of people in each frame. The cumulative count across all frames provides the total crowd count for the entire video. The fourth module is CNN Accuracy and Loss Graph. This module is responsible for plotting the accuracy and loss graphs of the CNN model during its training phase. The accuracy graph shows how well the model performs in predicting crowd counts on the training and validation datasets over epochs. The loss graph indicates the reduction in model error during training. These graphs help visualize the CNN model's learning progress and can provide insights into potential overfitting or underfitting issues. Execution. For the execution of the project, we need to open the code folder. This is the code folder. This is the MAUL dataset. In this project, we have trained CNN algorithm with MAUL dataset, and this trained model can be used to predict count of crowds from any image or video. MAUL dataset contains the frames of demo.m, MAUL feed, MAUL GT, perspective, readme. This is the model folder. This folder contains pickles files stored, which contains algorithm information. These pickle files can be loaded into the project code during runtime to utilize the trained models. And this is the test images folder, in which we have the test images which we have used during the execution of the project. And this is the videos folder, in which we have the test video which we'll be using in the project during the execution of the project. Crowd counter, data, test, test train. These folders are the Python files which we have used in the main code for the execution of the project. And this is the main code file. This is run.batch file. Instead of executing our project in the command line interface, we have created Windows bat file to execute the project. Double click on run.bat file. So this is the graphical user interface. We have created this GUI by using Tkinter library in Python. By using GUI, we will interact with the project. Click on load CNN model to load the model. So we can see CNN model is loaded and we got CNN accuracy as 100% on mol dataset. Now click on upload image and count crowd to upload the image and then count the crowd. So here I am applying the first image and open it. So we can see on top of the image I got the estimated crowd count as 42. Now I'll close this graph. We'll select another image, say 6, open. So here we can see on the top of the image I got the estimated crowd count as 29. In this way we can get the count of the crowd by applying any of the images. Now click on upload video and count crowd to upload a video. I'm applying the first video, that is airport, open. So here we can see this is the video in which people are coming and going in the airport. So on the top of the video I have the estimated crowd count 36. So here we can see that the crowd count is continuously changing because continuously people are coming and going. Now click on CNN accuracy and loss graph. So here we can see that x-axis represents the iterations and y-axis represents accuracy or loss. Red line represents loss values and green line represents accuracy values. And in above graph we can see accuracy get increased with each increasing epoch or iterations and loss values get decreased. Accuracy reached to 100% and loss reached to 0%. Higher accuracy and lower loss values make CNN model accurate. We'll close the graph. And the final conclusion of the project is crowd counting system project accurately predicts crowd counts in photos and videos using a trained convolutional neural network and the model dataset. The 4 modules, which include load CNN model, upload image and count crowd, upload video and count crowd, and CNN accuracy and loss graph, work together to provide an effective and user-friendly application. The system performs well in crowd counting, making it a useful tool in variety of real-world settings such as crowd control, event planning, and public safety. The accuracy and loss graph provides information about the performance of the CNN model. Overall, the implementation of the project advances crowd analysis and aids decision-making processes in a variety of scenarios.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.